Welcome to aminacademy.com. In statistics and econometrics, let us discuss about descriptive statistics. Some introduction. It is often useful to organize or arrange a body of data into frequency distribution. This breaks up the data into groups or classes and shows the number of observations in each classes. The number of classes is usually between 5 to 15 you can keep. A relative frequency distribution is obtained by dividing the number of observation in each class by the total number of observation in the data as a whole. The sum of the relative frequencies must be equal to 1. We'll discuss further about descriptive statistics. It refers to a set of methods used to summarize and describe the main feature of data set, such as its central tendency, variability, and distribution. These methods provide an overview of the data and help identify patterns and relationships between the data set. Descriptive statistics defined as show and summarize the basic feature of a data set found in given study, presented in a summary that describes the data sample and its measurements. It helps analysts to understand the data better. Descriptive statistics represent the variable data sample and do not include theories, inferences, probabilities, or conclusions. That's a job for inferential statistics. Here, descriptive statistics is represent the available data sample and do not include theories. Descriptive statistics, some examples. Look at this example. Students' grade point average, that is GPA. A GPA gathers the data points created through a large selection of grades, classes, and exams, then averages them together and presents a general idea of the student's mean academic performance. Note that the GPA does not predict future performances or present any conclusions. Instead, it provides a straightforward summary of students' academic success based on values pulled from the data. From the data set, some numbers, for example, 2, 3, 4, 5, and 6, that is total is equals 20. Look at here, that is first we have to do sigma x. Total of available data is 2 plus 3 plus 4 plus 6, 5 plus, which gives 20. Now it is 1, 2, 3, 4, 5 set of numbers, 5 number of numbers are there, then equal mean equal sigma x over number of numbers, that is 20 by 5 gives 4. The mean mark is 4. The descriptive statistics break down into several types, characteristics or measures. Some authors say that there are more types also, others say 3 or even 4. Distribution, that is also called frequency distribution. What is that? Data sets consist of a distribution of scores or values. Statisticians use graphs and tables to summarize the frequency of every possible value of variables, rendered in percentage or numbers. For instance, if you held a poll to determine people's favorite Beatle, you had set up one column with all possible variables. For example, John, Paul, George, and Ringo. These are the names of the person, respective number scores you have to write next to it. And another with the number of votes. Statistician depicts frequency distribution as either a graph or as a table. We can describe this. Measure of central tendency. Measure of central tendency estimates a data set's average or center, finding the result using three methods: mean, mode, median. These are central tendencies of the distribution of marks or votes, something like. First, we will discuss mean. The mean is also known as capital M and is the most common method for finding the averages. So the data set would be the some entries 6, 8, 7, 10, 8, 4, 9, like this distribution is given, and the sum of those values is 52, that is sigma x is 52, adding all numbers given equal to 52. There are 7 numbers are there, therefore mean equal sigma x over n is 52 by 7 is 7.3 is a mean of these entries. Mode. The mode is just the most frequent response value. Data sets may have any number of modes, including 0 to other numbers. You can find the mode by arranging your data set order from the lowest to highest values and then looking for the most common responses. So using this study here, these numbers are given by. Here we have to check whether which number is most frequently available. Here 4 is one time, 6 one time, 7 one time, 8 is two times, and others are only one time. Therefore mode equal to 8 because it is frequently available here. That is more frequently. That is 2 times it's available. Median. Finally, we have the median defined as the value in the precise center of the data sets. Arrange the value in an ascending order and look for the number in the set's middle. In this case, the median is 8 here. For this is already this is arranged. So 4, 6, 7, 8, 8, 4, 6, 7, 8, 8, 9, 10. Here that center is median is 8. Suppose here even number of numbers is there, means we have to take two middle numbers, add them and divide by 2, that is our median. Here median is directly 8 here. Variability, also called dispersion. The measure of variability gives the statistician an idea of how spread out the responses are. The spread has three aspects: range, standard deviation, and variance. Range. Use range to determine how far apart from most extreme values are. Sort by subtracting the dataset's lowest value from the highest value. Once again, we turn, this is a dispersion given. Here it's arranged in ascending order. Then highest is 10, lowest is 4, subtraction is 6. So the range is 6. Standard deviation. This aspect takes a little more work. The standard deviation is your data set's average amount of variability, showing you how far each score lies from the mean. The larger your standard deviation, the greater your data set's variable. Here, these are the sets you have to follow, set of steps you have to follow. First, list the scores and their means. Find the deviation by subtracting the mean from each score. Square each deviation and total up all the square deviations. Divide the sum of square deviation by n minus 1. Find the results of square root. Here, with one example, we can understand this concept. Here, that will make a small table here. This is a x value here, difference, that is x minus x bar, then squaring the d, that is d square. These are the sets we need. Here the given values are 4, 6, 7, 8, 8, 9, 10. Then the sum is here 52. Before that, you have to find the mean. X bar is the mean, is 52 over 7 items are given, which is approximately equal 7.3. That our x bar is 7.3. That means you have to write it x minus 7.3. So we have to subtract x minus 4 minus 7.3, 6 minus 7.3, like, which gives minus 3.7, then 1.7, minus 0.3, 8 minus is 0.7, 0.7, 1.7, 2.7. So we will find the addition of the things. Here we find the addition, that is right here, minus 3.7, minus 1.7, minus 0.3, minus 0.7, minus 0.7, no, plus is there something, minus 3.7, minus 1.7, minus 0.3, plus 0.7, plus 0.7, plus 1.7, plus 2.7, plus 2.7, which gives 0.1. Our sigma variation, that is sigma d, is this one. Then d square, we have to find d square of this. 3.7 square, 3.7 into 3.7, 13.69, 1.7 into 1.7, 1.7 into 1.7, 2.89, all positive. Then 0.09, 0.49, 0.49, 1.7 into 1.7, 2.89, and 2.7, 2.7 into 2.7 is 7.29. We'll add them, that is sigma 13.69 plus 2.89 plus 0.09 plus 4.9. No, plus 0.49 plus 0.49 plus 2.89 plus 7.29 plus so 7.29 equal to 27.83. Here, divide the sum total by deviation is n minus 1. Therefore, sigma d square by n minus 1, which is equal 27.83 divided by 7 minus 1 is 6. So, which is 27.83 divided by 6 equal this variance equal 4.64 approximately. Then standard deviation is square root of this, square root of 4.64 equal 2.154. 154. This is a standard deviation. Now further, so far we have done something about measure of central tendency, types of descriptive statistics, and what is descriptive statistics. We have done. Please subscribe our YouTube channel.